Hey guys, in this tutorial you're going to learn about soft body physics in iClone. These are a couple of various examples that demonstrate the capability of iClone's soft body physics engine. You can animate objects like soft balls and flags naturally and easily using soft body physics. The first thing you'll want to know in doing soft body physics simulations is the difference between real-time and frame-by-frame playback. You can see that when I play this default template scene in real-time mode, the results will be pretty bad because the calculations are done too quickly. When I switch over to frame-by-frame mode, the results will be slightly slower, but without the errors of the previous playback. So when you're dealing with soft body physics, it's always a good idea to use frame-by-frame playback. Okay, now I'm going to introduce you to the default cloth templates in the soft body physics area of the props section. I'm going to import in the three main types of cloth here in wireframe view to show the difference. You'll see that the first one I import in, the 16x16, has way fewer polygons than the others, and its animations will be a little stiffer as a result. Here's an example of how they will be different in pixel shading mode. I'm going to import in the 16x16 cloth now, and rotate and raise it above the ball, which has a rigid body static physics state. When I play back, you will see a couple of things. The first is that the cloth will seem kind of rigid, and the other is that the ball will appear through the cloth. Don't worry about the material issue right now, I'll show you how to fix that later. For now though, I'll import in the 32x32 cloth and play back. Notice now how there is more detail in the cloth and it will drape slightly better. When I do the same with the 64x64 cloth, you will see a significant difference not only in the cloth material, but also the speed the cloth is falling. It is falling slower because the computer is doing more calculations as a result of the more detailed mesh. Okay, so now I'm going to demonstrate how to fix the material breakthrough using an option called the collision margin. If I select my cloth and press the Shift F9 hotkey, I can open the physics panel. You can see at the bottom that the collision margin is currently set to a value of 3. This determines the amount of space between the cloth and any other physics object. If I enter in a value of 5, you will see that there is less breakthrough in the collision, but we still need to adjust it further. I'll move it up to 7, and now you'll see the results are a lot better. The mass of your cloth will also affect its interaction with other objects. Observe that if I increase the mass of my cloth, it will fall heavier and nearly right through the sphere. Another way to reduce material issues with falling cloth is to increase the lift. You'll see when I do this that there will be an additional upward force on the cloth, and it will land more gently, which makes the calculations easier. Damping also has a similar effect. However, the damping setting just restricts object movement, causing it to slow. So naturally, an object falling slower will likely have better physics collision results. Now if you ever want to preview your scene without the collision, you can turn off the soft versus hard collision in the physics panel. When I do that, the cloth will now fall right through the sphere. If I toggle it back on, the results will go back to normal. Alternately, I can also toggle all soft body simulations in the scene on or off. If I go to the top right of the work window and do that, you'll see my cloth won't fall at all, as its properties are not being calculated. Some of the cloth templates are held up by dummy objects for various simulation purposes, such as a flag. You can see here that I have a flagpole, and what I'm going to do is import in one of the cloths with 2 pinning dummies. I'm going to resize that a bit here and make it more suitable for our flagpole. After that's done, I can select both of the objects and use the Align tool to line up the 2 objects. Then it's just a matter of moving and rotating the cloth to match up with the pole. Make sure that your dummy arrows are on the side touching the pole. When I've finished positioning it, I can play back and you'll see the flag fall while the dummy objects pin it up. I want to attach the cloth to the pole, so it will follow the movements. So to do that, I need to select the cloth, Then click the Attach button in the Modify panel, and then select my pole. Now the flag will follow the animations of the pole. Let's delete one of the dummies here now, and see what happens. You'll see that the flag will only be held from a single point now. You can also animate these dummy objects, which I'll show you later. If you want to customize your cloth, you can do that too. You'll need to go down into the Scene Manager and specifically select the cloth material though, as this physics cloth object is actually made up of the dummy and cloth subprops. Once you've done that, double-click the Diffuse swatch in the Modify panel and select your image. You can rotate it easily using the Rotate function in the Modify panel like so. I have the physics panel open, and the first customizable value I'm going to demonstrate is solver iterations. To put it simply, this determines the level of detail of your calculations. You can see that when I put this up to its maximum value of 50, the playback will become much slower due to more calculations, and there will be more detailed folds in the flag. Bending constraints will also affect cloth strongly. There are only two values, 1 and 2, but you can see that if I put it down to 1, there will be more creases in the material, as there is less constraints. I can add in a little bit of damping to make the flag fall more evenly, and decrease the solver iterations slightly. This will create a pretty decent result like this. Let's animate this flag now. I want to make a back and forth waving motion, so what I'll do first is change the orientation of the pole's axis. By simply pressing Reset Transform, I can make the axis reset to 90 degrees. I can then use the X-axis rotation gizmo to move it around in a semicircle. Just move the timeline ahead a little, rotate to the other side, and then repeat the process one more time. This will be the result. You can see the natural flowing motion of the flag going back and forth. Okay, so here I have a rigid body sphere that I want to change into a soft body object. Easy enough? I can just simply go to the Physics panel and select Soft Body Physics, and the object will now be soft. But how soft? That depends on my settings. You can see here that there are a few templates I can choose from that give all kinds of predefined values. Take a look at the various different values and results as I demonstrate each one. I'm going to give you a brief intro to these values, so I'll set the values here back to general. The first thing I'll demonstrate is stiffness. If I put that down, you'll see less bounce on the object, and it will kind of just lay there half inflated. Pressure is important for bouncing balls. If I even put that up to 10, the sphere will expand and float away. To counteract this, I can increase the mass of the object. Pose matching will give a strange result to spheres. If I raise this value up to 100 and play back, you'll see that the ball will struggle to maintain its original proportions, even to the point of sinking through the infinite plane on the floor. A significantly lower value will give a better result. Volume conservation will do just that, struggle to maintain the object's volume despite interactions with other objects. This is different from pressure and shape matching in that volume conservation only serves to keep the volume of the object the same. You can see a better example if I reduce the stiffness to 0. If the volume conservation is low, it will just fall and limply sit there half inflated. When I increase the volume conservation, the sphere will maintain its volume despite having a stiffness of 0. A higher mass will cause the ball to fall faster and squish down a bit more upon impact with the ground. If I reverse the position and bring in this cloth pinned by 4 dummies, I'll show you some better examples of these values. See that when I play back, this ball will bounce off the cloth and continue to bounce. Let's go into the Scene Manager and select the cloth to adjust its values slightly. First, the stiffness. When I put that down to 10, you'll see that the ball bounce will be reduced significantly. I'll put it back up to 100, but this time increase the mass. This time the ball will barely make an indent in the cloth, as its mass is insignificant in comparison. Decreasing the bending constraint will again create more slack cloth like you saw in the previous example. A higher solver iteration value will again slow down the playback but create more detailed creases in the cloth upon collision. Putting the volume conservation up even a little will cause the cloth to go all wacky, as there really isn't any volume to conserve in the first place with the cloth. However, pose matching is quite effective in this type of simulation. By putting it up even a little, I can see a difference in how the cloth maintains its shape better. If I put it up to 100, the sheet will no longer even seem like a sheet, but rather like the top of a mattress. Cloth with pins can be animated as well. I'll import in this cloth with 4 points and go ahead on the timeline first. After I've done that, I can grab these points on the cloth and lift them up to combine them together at the top. You can animate these dummies in any way, just like regular objects. If you want to make the dummies invisible, just press the Ctrl-D hotkey and they will disappear. This works with any dummy object, including infinite planes. Stay tuned for more soft body physics tutorials that will give you even more insight into the crazy world of iClone physics.